So we said that we can have one of these 6 different scenarios. Of course, these are some well-known scenarios. We may have other scenarios as well. Let's go through these scenarios. Okay, so this is a table from your book, actually. When we have single cash flows, we may have these situations. We are given this present value and we want to find a future value. So an example, a firm borrows $1,000 for 8 years. How much must it repay in a lump sum at the end of the 8th year? Okay, we borrow 1,000 now and we pay it after 8 years. And the interest rate is 10% given to us. Number of periods is 8. Okay, so we can represent this as a cash flow like this. We are borrowing currently. That's why this is an upward arrow. Okay, we are borrowing. It means that the money comes into our pocket, cash inflow. And the number of periods is 8. And we want to find the equivalent future values. So we can state this as what is the future equivalent at the end of 8 years of 1,000 at the beginning of those 8 years. Okay, so this is actually the equivalent terminology. And the solution to this is we want to find the future value given this present value. So we will use this factor. Of course, you can use the formula to find this as well, but with this factor, this is F given P. Present is given. We are trying to find the future with 10% interest rate for a period of 8 years. And you can just go to the tables in your book to look for this value. First, you need to find the table with 10%. Then you need to find the row for the 8th period. Then you should look at this F given P, and you will find that the factor is 2.1436. And simply when you multiply this 1,000, you find the future equivalent. In opposite to this one, we may have this scenario, future value is given, and we want to find the present value. For example, a firm wishes to have $2,143.6 8 years from now. So in the cash flow, after 8 years, we want to have this future value. Then what should be the amount that we should deposit to the bank account for 10% interest rate now? Okay, we want to find the present value. And for this one, the factor that we are going to use is P given F, 10% and 8. And we will find this from the table, this value, and multiply it with the known future value to find the present value. Okay. With these uniform series, so this part until now we did these calculations, they are simple. But this part is new to us. So what can be? We are given an equivalent payment series, uniform payment series for a period of time, and we want to find its future value. Okay, so let's look at an example question. If 8 annual deposits of this much, each are placed in an account, how much money has accumulated immediately after the last deposit? So we are depositing the same amount for 8 years into a bank account. But look, be careful here into this cash flow. So this time 0 is here. And first deposit occurs at the end of first year. It is very important. It's extremely important. Okay, so the first deposit occurs at the end of first year. If instead of this, if you represent the payment in this way, so now I am making a deposit. In year 1, I am making a deposit, I mean at the end of year 1. Then at the end of year 2, I am making a deposit. So let's say that this is 8th year. This is the 7th year. 7th year, I will make a deposit. And in the 8th year, if you also make a deposit, now in this case, in total you have 8 plus 1, 9 deposits. Okay, you deposited 9 times. If you just start depositing now, before waiting the end of the year. And then if you want to calculate the equivalent future value of this one, this formula will not be correct. This formula, this factor over here assumes that the first payment occurs at the end of the first year. So this factor is for this one, not for this one. But of course, if you say, then can't we find the equivalent future value of this one? Of course you can find it, but you cannot use this factor to find it. You need to use an additional thing. What you can do is you can assume that, okay, there is a single cash flow at time 0, which is this much. Sorry, where are we? Which is this much. And then we have another cash flow which starts at time 1 up to 8, and the deposit amount is this much. So simply, I divided this whole cash flow into 2 parts. One part is suitable for me to use the factor, and the other one includes all the cash flows which does not appear in this factor. And for this one, I can use F given A, okay, 10% and 8. And for this one now, I need to move it how many periods? So to 1, to 2, to 3, and I need to move it to 8. It means that 8 periods. And how do I do it? This time I need to use F given P, 10% and 8. So if I add up these 2 values, I can find the cash flow for this one. But in this question, if it is not mentioned that the first payment appears just now, you should always understand that the first payment occurs at the end of year 1. And if this is the payment series, then this is the factor that you are going to use. Okay? So be careful. This is extremely important for uniform payment series. And now, okay, please go to this table, 10% table, and go to this 8, number of periods 8 in your book. And at the top, look at the 3rd column. The 3rd column of the table is for F given A. Okay, so this factor is your book is given there, and you should be able to read this, 11.4359. Okay, as you can see, if you have such uniform payment series, the factor is also given in your book. Another scenario is similar to this one, but instead of finding the future value for given annual amounts, we want to find, or we find the present value. And an example question can be like this. How much should be deposited in a fund now to provide 8 end of year? So this EOY means end of year withdrawals of this much value. Okay, we want to deposit some amount here that we don't know, but after that, at the end of each year, for 8 years, I want to deposit exactly this amount. How can we find it? And we find it in this way. We want to find the present value given this annual amount of this much. So we will use P given A, 10% and 8. And again, look at the same table in your book. For 10% interest rate, go to the row for 8 periods. But now look at the, if you count the first column, look at the 5th column, which is for P given A. And then you should read this coefficient or this multiplier over here, okay? 5.3349. And if you multiply it with the given equal amounts, then you will find the present value of this much. Again, similar to these, instead of given A finding P or F, we can have given F and we want to find the annual amount. So the future value is given. We want to find how much shall we deposit into this bank account each year so that we will collect this much. And in this case, the factor that we are going to use is this. A given F, again 10% and 8. And if you look at this sixth column of the table, it is for A given F. And when you look at the corresponding row and column, you should be able to read that value from your book. Okay, this is the sixth one. So writing the correct factor is important because, for example, A given F and F given A are totally different things. Similarly, A given P, P given A are totally different things. So you should write first, you should write which factor to be used correctly, and then you should look at that value in your book again correctly. And finally, we may have given this initial amount, present amount, and we may want to find the equivalent payment series. So, for example, you buy a loan, you receive a loan from a bank for $1,000 now, and you want to pay these in equivalent payment amounts for 8 years at the end of each year. Okay, then this is the factor that you are going to use. A given P, 10% and 8, and in your table, this is the seventh column. Okay, so if you look at your book, the tables, now we learned the columns, the factors for the F given P, P given F, F given A, P given A given F, and A given P. So the last two columns for P given G, P given G, and A given G, we haven't seen them yet. We will learn them later. But they have the same idea. And this G is for linear gradient series. Okay? When we have linear gradient series of payments, we will use these factors and we will learn it later. And as I told you, this is an example of a table from your book with 12% interest rate. Okay, now let's do some calculations and let's learn how to relate the annuity amount to its present or future value. Okay, when we say an annuity amount, we are talking about the same amount of payment for n periods without any interruption. I is the interest rate, P is the present value, F is the future value. Okay, so this is the kind of annuity, the cash flow, and either we want to find its future value, but look, the first one starts at the end of first year, and the last one occurs at the end of nth year, and we want to find the future value at the end of nth year. Be careful, this is extremely important, as I say. Okay, so the first one should be at the end of first year, the last one should be at the end of nth year, and if we want to find the future value, we find the future value at the end of nth year using this factor formula. You should memorize this all the time. You can ask, but I want to find, let's say, the future value in n plus first. Let's say this is 10th year, and I want to find the future value in year 11. Can I find it? Yes, of course you can find it. But you should do an additional calculation to find it. What kind of additional calculation? I'm talking about this. First, Consider these equivalent payment series and find its equivalent value. Let me write this f prime at the end of year 10. So what will it be? This f prime will be equal to this a, then what's given? F given a, interest rate, and number of periods, which is 10. So this f prime is equal to this one. Now, what do I want to do? I want to find the future value for one period later of this f prime. So this f will be equal to f prime times, I want to find future value given present. So now, with respect to this f prime is a later, is an older transaction. It's present, this is future. That's why I wrote f given p, I, and 10. So simply, if I combine this f prime into here, this formula into this, I can say that this f is equal to a times f given a, I, and 10 multiplied by f given p, I, and 10. Sorry, this last one is not 10. I am just moving it only one period ahead. Okay, so this will be 1. Now this formula calculates the future amount of such a transaction at the end of year 11. But if you want to find its future value at the end of year 10, only this part is enough. This part is necessary if you want to find its equivalent value at the end of year 11. But now, if you say that this is like this, so this is 10th period, and this is the 11th period, and I have another A, and I want to find this future value. Then what should I do? Now look, all these equivalent payments continue for 11 periods. Simply in this case, f is equal to a times f given a, I, and 11 this time. So you don't need to do double calculation and etc. You just change this to 11 instead of this 10. Now I'm using 11. Okay, so what you should understand from here, you should understand this. This given uniform payment series, if you want to find its future value at the end of year n, then if you want to use this factor, which is f given a, I, and n, this factor finds the future value at the end of year n if the first equivalent payment is after year 1 and if the last one appears at the end of year n. That's it. And similar to this one, if you want to find the present value of such an uniform payment series at time 0, the present value at time 0, then we will use this factor, which is p given a, I, and n. Okay, this factor is for this payment series to find its equivalent value at time 0. Okay, so at the beginning, you may feel a little bit confused maybe, but it will be clear. Okay, now, but how can we calculate this factor? Because you know, when it was finding this f, the formula was p times 1 plus I to the power n. And simply with the calculators, we can calculate this one. But if the payment series is something like this, how can we calculate its future value? Simply, you can do this. You can find the future value of all of these one by one. Okay, you find the future value of this first one. From here, you find its future value. Then you find the future value of this one. You find the future value of this one by one. And if you do it, for example, the future value of this first one, it is a times 1 plus I to the power n minus 1. Okay, I'm moving this to this period n, but I'm starting from 1. It means that I'm moving 1, 2, 3, 4, n minus 1 periods forward. So it is the fundamental theorem, fundamental law. Then for this one, the second one, I want to move it one by one. Okay. Then it is this time to the power n minus 2 because I started from 2 to n. And the third one, move it. The fourth one, move it. And the last one, if you look at the last one, it's already in period n, so you don't need to move it. And for these, all these values, just add them up. Okay, sum their values. You will obtain this. A times 1 plus I to the power n minus 1, n minus 2, up to A. Then, if you combine everything under this A parenthesis, with series formula, sum formula, you can obtain this. Okay, this is the formula of finding a future value given an equivalent values. And simply, we represent this formula as a factor which is f given a, I, and n. Look, for the others, for p given f or f given p, the formulas were very easy. 1 plus I to the power n or minus n. The formulas are easy. But when you move to the uniform payment series, the formula is more complex. Therefore, instead of using this formula, using these factors may be more convenient. But still, you can use this formula to make the calculation as well. Again, in this course, we expect from you to be able to use both of them. By the way, you don't need to memorize these formulas. You don't need to memorize it. The only formula that you need to memorize is this one. F is equal to P times 1 plus I to the power n. You should know this. Otherwise, you don't need to memorize this formula. Okay, so this is how we calculate a future value given an annual equivalent. This is the formula, and also you can find you can use the factor table to calculate this value. Okay, let's solve some example problems. It says, how much will you have in 40 years if you save 3,000 each year and your account earns 8% interest each year? Okay, so it says 40 years. 40 years. The first thing when you get such a question, the first thing is to sketch the cash flow diagram. When you correctly represent the question in a cash flow diagram, then it's very easy to solve it. Okay, so these kind of problems consists of two parts. The first part is to sketch the cash flow diagram. The second part is to, depending on that cash flow diagram, calculate the final value. Okay, so this is time 0, and the time in this case is years. Okay, so this is the end of year 1, this is the end of year 2, and you don't need to write everything up to 40 because it goes up to 40. It will take a lot of time to write everything. And it says that if you save 3,000 each year, and if nothing special is mentioned, for example, in some questions we can say that the first payment starts now, and etc. Some additional information. But in this question, there is no additional information. It means that this 3,000 starts at the end of year 1. Okay? We will always assume the payments are at the end of year 1, at the end of the years. For the second, again, we will save 3,000. For the third, again, 3,000. And we will continue to do this for 40 years. Okay, so it will be 3,000 at the end of year 40 as well. And it says that how much you will earn in 40 years. So we are asked to find this future value of all these savings. And the solution is simple. This annual amount multiplied by F given A, interest rate, and the number of periods. Okay, so the first thing is to sketch the cash flow. Second thing, write the formula. Third thing, look at this in your table, okay, and find first 8% interest rate, and then find period 40, and then find F given A. I'm just looking at it now. Please do yourself. And you should find this value to be 259.0565. And when you multiply this by 3000, you will obtain the result. Okay? The result is this much. That's it. Very easy. But of course, this is the easiest question. For example, when in the primary school, you learn this multiplication, and then your instructor asks you, what is 2 times 2? And then you answer that it's 4. So this answer, this question is now this. Of course, in your exams or quizzes, you will not have such simple questions. This is just 2 times 2. But if you don't understand the idea, even in the simple question, then it will be impossible for you to understand more complex cash flows. Another question, how much would I need today to provide an annual amount of 50,000 each year for 20 years at 9% interest? Okay. First thing, sketch the cash flow diagram. Second thing, write the formula using either the interest formula or the factor. The third thing, calculate the question, what is asked. Okay, cash flow diagram. It says that for 20 years, an annual amount of 50,000. So at the end of year 1, I will, let's say, need this 50,000. At the end of year 2, I will need the same amount. And I will continue to do this for 20 years. And what should be the amount that I deposit, for example, into my bank account now, so that with 9% interest, I will have these $50,000 each year? And the solution is P equals to $50,000, then P given A. So A is given, look, the annual amounts is given. We know it. We want to find P. So therefore, P given A, interest rate is 9%, and the number of periods is 20. And again, since nothing is said here about the payments, annual payments, we assume that these payments occur at the end of each year. The first one starts at the end of year 1, and the last one occurs at the end of year 20. And again, you should look at this factor in your book. Go to the table for 9% interest rate, go to the period of 20, and have a look at this P given A, and you should find this value of 9.1285. And when you multiply this 50,000, you would obtain this. So if you deposit into a bank account of this much now, with a 9% interest rate, for 20 years, each year you can withdraw $50,000. Okay, now another example. When the interest rate, number of periods, and the future value is given, let's try to find the annual amount. Okay, let's assume that the future value is 5,000, number of periods is 5, and the interest rate is 7%. How can we find this? By the way, the factor, this factor, is sometimes named as sinking fund factor. Okay, so each of these factors are given a name in economics, and this factor is called a sinking fund factor. And what do? We can either use the formula, which is this one, or we can use the factor. By the way, whenever you got this formula, you can use it to find A, but if you want to find the value of F, simply you can move this to this side, and A divided by I1 plus I to the power n minus 1, and this will be the formula to find F. Okay, this is simple mathematics, just mathematics, don't be confused. Everything that you can do with mathematics, you can do with this formula. Okay, now how do we find? We want to find A, the future amount is given. First, of course, thing is to sketch the cash flow. We need 5,000 after 5 years, and what should be this annual amount. We want to find it. And for that, we will multiply this future amount of 5,000 with A given F, 7% and 5. So if you look at your table, your book, go to this 7% interest rate table. Go to this 5 number of periods and go to A given F, and you should find this factor to be 0.1739. And multiply it by 5,000 and you should find this amount. If you want to use the formula, you will just plug in the values. Here, we need to write 0.07 instead of I. Again here, 0.07, and this F is 5,000. Use your calculator to calculate this value. And as I told you, Excel is a very powerful tool to solve these questions, and the formula in Excel to find the annual equivalent values, so it's PMT. Okay, this is the interest rate, this is the number of periods, this is the future amount, this 0 is the present amount. Okay, in the formula, one of the arguments is also the present amount, and with this one, when you write this into a cell, you can obtain the same result. Now that we have an interesting question here, an interesting example. We will compare 3 different investment plans. Assume that you are in your 24th birthday and you want to make an investment now, or you have 3 different alternatives now, so that when you reach your 65th birthday, you want to have the maximum amount of money accumulated in your bank account. In the first alternative, what you are going to do is, you will start immediately at the end of this year to deposit $2,000 into a bank account. And you will continue to deposit this $2,000 for 10 years. But after 10 years, you will stop depositing. But the accumulated money will remain in the bank account until this 41st year, which corresponds to your 65th birthday. Okay. So we deposit this 2,000 for 10 years, and then we leave that money in the bank account, and it continues to earn interest. And in our 65th birthday, we will withdraw the whole amount. In the second alternative, for the first 10 years, we will not deposit anything, but starting from the 11th year until the 41st year, we will deposit $2,000 for 20 years. Okay, we will deposit $2,000. Here, we only deposit for 10 years. And again, we will find what will be the accumulated value at the end of this 41st year. And as the third alternative, immediately at the end of this first year, we will start depositing an amount of 2,000, and we will continue to do this until our 65th birthday for 41 years. And we will try to find what will be the future amount of this. Now, let me ask you, without solving anything, in which of these alternatives, these are alternatives, we are going to select one of these alternatives. In which one of these alternatives the future amount will be the largest? Okay, the future amount, let me say this is F1, this is F2, and this is F3. Which one will be the largest? Please write your answers into the chat board. Order them, not just the highest one, but rank them. For example, 1, 2, 3. 1 is the highest, 2 is the second, third, 3 is the least. Or 2, 1, 3. Okay, write in this way. Which one will be the highest? There are 32 students currently attending, so I'm waiting from each one of you. Please write your answers. I got answers. Some of you said 3, 2, 1. 3, 2, 1. Some of you said, let me see, 3, 2, 1, 3, 2, 1, 3, 2, 1. Yes, yes, yes. 3, 2, 1, 2, 3, 1. I get one answer. 2, 3, 1. And then I'm looking at the answers. 3, 2, 1. 3, 2, 1, 3, 2, 1, 3, 2, 1. Yes. So most of you said that 3, 2, 1. 3 is the largest. 2 is the second. First is the last. And only one of you said that 2, 3, 1. 2 is the largest, then 3, then 1. But the thing is, when we compare these three alternatives, for sure, 3 is the largest one. Because 3 continues, 3 includes the first one plus the second one. So this 3 is equivalent to the summation of these two. Okay? So therefore, this 3 would be the largest. But the counterintuitive thing is, you said that the second one is larger than the first one, because here we are making 20 payments, 20 deposits, but here we are doing 10 deposits. That's why you said that 2 would be larger than 1. But let's see the results. Let's solve it. First of all, how can we find the future value for this alternative? I want to find its future value at year 41. So this is an equivalent payment, uniform payment, but it continues only for 10 years. So if I just say that, okay, this is 2,000, the equivalent payment amount, then I'm going to find the future given this annuity. The interest rate is 8%. Okay. And if I write here 41, then it is wrong. It is not correct. Actually, this one is for this last alternative, when the payments continue for 41 periods. Okay, so this is not right. Then maybe you can say this is for 10 periods. But it's also not correct, because when you say only 10 periods, you find the future value at the end of year 10, the future value here. But I'm asking the future value here. This amount that accumulated in the bank account will stay in the bank account and will earn interest for the 31 remaining periods. Okay, then it means that this is f prime or f1 prime, the future value at the end of year 10 f1 prime. Now I need, in order to find f1, I will multiply this f1 prime by, look, this is a single amount now at the end of year 10, and I will take that single amount, look, this p, not a, it's p, because this f1 prime is just a single amount, and I will move with an interest rate of 8%, but now I will shift it 31 periods forward. So it will be 31. So you can just combine these two things, and you can say that this F1 is equal to 2000 F given A 8% 10 multiplied by F given P 8% and 31. And this is the solution. Now what you are going to do, go to your book, to the table, this F given A 8% and 10 years, okay, 10 and 8%, and F given A, it is this one, 14.4866. Now, on the same table, go to 31, but this 31 does not exist in the table. What you can do, either you can look at this Excel file, or you can use the formula, which is 1 plus 0.08 to the power 31, because this is just F given P. Okay, multiply this by 2000. And this will give you this F1, and not prime, but F1. This is the first one. What about the second one? How do we calculate the second one? And look, we don't have any payments in the first 10 years, but we have these deposits for the following 31 years. So actually, you don't need to consider this part. Just concentrate on the rest. And this F2 will be equal to this annual payment amount, which is 2000. You are trying to find F given A, interest rate is 8%, and these deposits continue for 31 years. That's all. Okay? This is how we find for the second one. And for the last one, I already wrote it. This F3 will be equal to 2000 that continues for 41 years. Okay? And when you do these calculations, look, the first one appears to be this much. The second one appears to be this much, and the third one appears to be this much. And this third one is equal to the summation of this one and this one. When you sum these, you will obtain this one, exactly. But the counterintuitive thing is, none of you said that the answer is 3, 1, 2. All of you said that 2 is larger than 1, but actually 1 is larger than 2. What is the reason? The reason is the time value of money. These 10 payments, although here you have 20 payments, although you have 20 deposits, these 10 deposits occur earlier than those 20 deposits. And these start to earn an interest earlier than the others. And after this point, what happens? You have an accumulated amount of money. You don't withdraw it. That money still remains in your bank account and still earns an interest for 31 years. And therefore, as you can see, this 314,000 something is significantly larger than this one. This is a good example that shows the time value of money. Of course, this significancy depends on the interest rate. If the interest rate was less, if it is, for example, 4%, then this may be, in that case, the second one may be better than the first one. Okay, so this result depends on the interest rate. If the interest rate is even larger, then the first alternative will be even larger than the second alternative, even more large. Okay, because it will start to earn large amount of interest for 10 years before than the other alternative. And at the end of the 10th year, there will be a large amount of money accumulated. And that large amount of money will continue to earn interest in the following periods. Okay, so this is the point that I'm going to stop. We will continue on this, but please review all these material. As I told you, this chapter is the fundamental chapter. If you don't know, if you don't understand how we find these present future values, the equivalent economic equivalencies for these uniform series, the present single cash flow, future single cash flow, and etc., at a later time, you will not understand the material.